Okay, so 3.2 on page 127. Proving figures are congruent using rigid motions. Okay. Let's get this a little bigger. Two plane figures are congruent if and only if one can be obtained from the other by a sequence of rigid motions, reflections, translations, or rotations, okay? So that's how you know if two things are congruent, is if you can get one from the other by using a sequence of rigid motions. Okay, so let's look at B on page 128. The two figures appear to be the same. You can map triangle ABC to triangle XYZ. And see, now we're not using the same letter. It's not A and A prime. So you got to try to figure out what goes to what. And I would say X would be A, Z is C, and Y is B. And when you look at it that way, you can see that every piece of this moves 90 degrees around the origin. So what we would say is it's rotation by rotation. Of 90 degrees. And we really probably should say counterclockwise. This is a rigid motion that maps ABC to triangle XYZ. So the two figures are congruent. And we know that the 90-degree rotation rule is negative Y X. And we could check, let's check. A is at 1, 2, 3, 4, -1. And X is at 1, 4. And let's see, A moves to the front, Y moves to the front and is opposite, and X moves to Y and stays positive. So that works, doesn't it? Okay, so let's flip the page. Okay, so on page 129, we're going to look here at the top, and it says that the definition of congruence tells you that when two figures are known to be congruent, there must be some kind of sequence of rigid motions that maps one to the other. So it's showing us that it's telling us that the two figures are congruent and wants us to find a sequence of rigid motions that maps one to the other. And then to give coordinate notation for the transformations we use. So let's look at B. And we need to show that ABCD is congruent. Remember, that's what this means, to JKLM. So let's think. If I reflect ABCD across the y-axis, it would mean that A is about here, B is about here, C would be here, and D is 1, 2, 3, 4, 1, 2, 3 over here. Now remember, reflecting across the y-axis means that however far each point is away from the y-axis, then that's the way we draw it on the other side. So if we did that, let's write it down here. Reflect across y-axis. Okay, now let's think here. What happens now? Well, all the points are in the same spot, right? I mean, K looks like it's where B is, L looks like it's where C, M, and J. And so it looks to me like, and J looks like where A is. It looks to me like they just moved. So if we look, and notice, by the way, that they made these by 2. 4, 6, 8, okay? Each line is 2. So A would be at, I'm talking about this A right here, would be at 3, 4. And the new A, which would be J, is at 1, 2, 4, 6, 6. So what happens? How about -6? Well, A moves over 2, doesn't it? Okay, and it's moving right, so we're adding 2. And then it moves down 10. So the translation down here, we're going to write reflected, reflect, and the rule is -x, y, and then we're going to write translation. I don't have room, so I'm not going to write the whole thing. Let me put it up here. Now I have. And I'm going to write x, and we said +2. That's the rule. And y -10. Now, let's go down to number 5. I'm going to pause the video and you do 5 and then check back with me and see if you were right. Okay, so here's your answer. And with the translation, be careful because notice again that these go by 2s. And I almost messed that up down there because of that. And now if you have any questions about that, we'll talk about it tomorrow. And that is the end of the video for tonight. I am going to stop before the Explain 3. So we will see you tomorrow. Don't forget all that work from 3-1 plus your drawing. You only have 30 minutes in class tomorrow to finish it. So make sure most of it is done before you get to class.